Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on the last part of a three-part video series on trigonometric functions for mathematics grade 11, and that is the tangent graph. In part 1, we focused on the sine graph, and in part 2, we focused on the cosine graph. Now in this part, which is the last part on the series, we're going to focus on the tangent graph. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on new videos we upload in the future. Also, don't forget to like this video and share it with all your friends on all social media platforms so the algorithm can make this video available to more people. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at number 1, functions of the form y equals to a tan theta plus q, which is basically grade 10 revision. We've looked at this. I've already done a video on this one. Please go watch the video. I'm going to also attach it on the description so that you can easily access it. Number 2, we're going to look at functions of the form y equals to a tan k times theta. We're going to look at the effect of k, the characteristics, which is basically your domain, your range, your asymptotes, and so on and so forth. And we're going to look at example 1, which illustrates how you work at examples with this type of form. Number 3, we're going to look at functions of the form y equals to tan in bracket theta minus p. We're going to look at the effect of p, the characteristics, which is your domain, your range, your asymptotes, and so on and so forth. And example 2 will showcase how we deal with problems of the standard form of this type. Number 4, we're going to look at example 3, which basically will show you how to sketch the tangent graph of any type or kind. Number 5, which is the last one, we're going to look at example 4, which will illustrate how to interpret the tangent graph in case you get a question that requires you to do so. We have a lot to cover, so let's start. First, let's look at the revision. Basically, this is functions of the form y equals to a tan theta plus q. The most standard basic one is y equals to tan theta, where you have a domain of between 0 and 360 degrees, and your asymptotes are at 90 degrees and 270 degrees. Your period is 180, which is different from the periods of the sine and the cosine graph. Keep that in mind. And your y-intercept is at the origin. Your x-intercepts are 180 degrees apart. From 0, that is the first one, and then the next one is at 180 degrees. The last one is at 360 degrees. And then your range basically includes all values of y. There is no restriction here. The only restriction is with the domain, where the domain is basically between 0 and 360 degrees, and your asymptotes, which is at 90 degrees and 260 degrees, are excluded from that because then the function is undefined. Those are the 2 points on the domain of the graph of y equals to tan theta that are not included in the domain because their function, they make the function of tan theta undefined. Now let's look at the general graph of y equals to a tan theta plus q, where your a is in general and your q is in general. Now let's look at the effect of q. Q basically in all types of graphs tells you the shift up and down. If your q is positive, then it will tell you how many units up the graph has been shifted. If your q is negative, it will tell you how many units down the graph has shifted. So if your y equals to tan theta plus 2, that means your graph has been shifted 2 units up, and this is what the graph will look like. This is your standard form. This is the basically the point of rest shifted 2 units up to make it easier for you to draw the graph so that you can keep the shape correct. Now let's look at the effect of a. The effect of a basically is on the shape, like with all types of graph, whether algebraic or trigonometric graphs. If your a is positive, then your graph will look up like a normal tan graph. But if your a is negative, the graph will look down. It will be reflected about the x-axis. In other words, it will be flipped upside down. Now, if your a is multiplied by a factor of 2, for example, that means your graph will meet your milestones, will reach your milestones twice as fast. For example, let's look at y equals to tan theta and compare that with y equals to 2 times tan theta. At the point where your y equals to 1 degrees, 1 unit, for example, in this case, and that should be, I think it's around 10 or 45 degrees. Yes, 45 degrees, that is 1. In the y equals to 10 theta, that is equals to 1. But notice that when your graph now is y equals to 2 times 10 theta, the very same milestone is reached at twice the amount, which is 2 in this case. So now, also notice that when your a is bigger, that means your graph is now thinner. So it will lie thinner inside of the other one, which is basically thicker. So if your a were 1/2, your graph will go this direction. Let me show you. Your graph will be a lot thicker or flatter than the standard y equals to 10 theta. That's how it would go. Now let's look at the characteristics in general of y equals to 8 10 theta plus q. Your period is 180 degrees. Your domain is between 0 and 360 degrees, but not including your asymptotes, which are 90 degrees and 270 degrees. Nothing has changed there. The range is still all values of y. The asymptotes are still at 90 degrees and 260 degrees. 270 degrees, I mean. The intercept, on the other hand, the y-intercept will be equals to q, 0 degrees and q. And your x-intercept, you just make y 0 and solve. So basically, depending on how the graph is shifted, your x-intercepts and the y-intercepts will be different. Now let's look at functions of the form y equals to 10k times theta. This is grade 11 work. This is the start of grade 11 work, so pay attention. Now let's look at the effect of k. K in all types of graphs so far that we've looked at, whether algebraic or trigonometric, tells you the period is going to be affected. The variable can be any other variable. It could be m, it could be y, it could be whatever they choose to make it, as long as it's right in front of your angle theta and it affects that theta, then you know that it will affect the period. So the period of a tangent graph, which is 180 degrees, notice how that is different from the period of the sine and the cos graph. It is half of that. So the period now becomes 180 degrees divided by the absolute of value of k, which is the variable that is placed in front of your theta. So for example, with y equals to 10 theta, you know that your period is going to be 360 degrees. Also, because your k is equals to 1, meaning that your period, when y equals to 10 theta, when your k equals to 1, that means then your period becomes, your period is simply equals to 360 degrees divided by the absolute value of 1, which is equals to 1. So that's 360 divided by 1, which is 360. What happens when your k is 2? This is how it affects your period. The period becomes 180 degrees divided by the absolute value of k, which is 2 in this case, which then gives us 180 multiplied by, you flip this one at the bottom down. So this is 2 over 1. So we're going to flip it upside down and it becomes 1 over 2, meaning that your period now is halved to 90 degrees, which makes sense because in all these types of trigonometric functions, remember the value in front of your theta, your k in this case, for example, tells you how many complete periods you will have in your normal full period. For this 10 graph, that is 180 degrees, meaning that you will have 2 complete periods in a span of 180 degrees, from 0 to 180 degrees. So it makes sense that your period now has been halved to 90 degrees. Now what happens when your period, your k is equals to a half? What happens to the period? The period becomes 180 degrees divided by the absolute value of 1 over 2, because that is our k. Theta over 2 means 1 over 2 times theta. It means exactly the same thing. So that will become equals to, so that will be equal to 180 degrees multiplied by, you flipped the fraction below upside down, so that becomes multiplied by 2 over 1, and that becomes 180 times 2, that is 360 degrees, meaning that it will take a full span of 360 degrees to get a complete cycle finished, meaning that your normal period of 180 degrees will only accommodate half of the normal tangent graph. And that is how your period is affected by K. Now let's look at your general characteristics. We're going to need this board, that's why I'm cleaning it. Let's look at your normal characteristics. What are the characteristics of this graph of this standard format? The characteristics, your domain. Now we're going to focus on the center branch. Very important. Focus on the center branch, and the rest is easy to duplicate on either side, the left hand side or the right hand side. Notice that with this one, we made our period go from all the way to minus 360 degrees to 360 degrees to accommodate the duplicity of the graph and the repeated pattern, so you can see it very clearly. So keep that in mind. Now the domain that we're going to look at is one center branch. One center branch, for example, for the graph of y equals to tan of theta, where your period is 180 degrees and your first asymptote is at 90 degrees. Here is the first asymptote, and you'll see exactly what I'm talking about. The first asymptote is at 90 degrees. Here is 90 degrees, 30, 60, 90. Asymptote is at 90 degrees. Let's put that on there. Let's make that red so it matches with the graph. Let's make it a bit thicker. All right, now let's duplicate that onto the left hand side, because it must also go to the left hand side. 1, 2, 3. This is in increments of 30 degrees, so I know that when I count 3, I'm counting 90. So these are our asymptotes on the middle branch. That is the center branch. This is a full period of 180 degrees. This is 90 degrees, and that is negative 90 degrees. So in total, that's 180 degrees. That's what we mean by the center branch. Now, the domain of this center branch is negative 90 degrees and 90 degrees. For the graph of y equals to tan of theta over 2, the period is 360 degrees, and you will see what happens to the center branch. Let's look at the general equation of the asymptote for this one. The asymptote usually is at negative 90 degrees, and the other one is at 90 degrees, right? But with regards to K that affects the period, that will be negative 90 degrees divided by the absolute value of K on the left hand side, and then 90 degrees divided by the absolute value of K on the right hand side, which now brings us back to the domain. The domain basically includes these asymptotes, because you need to keep that in mind, that you've got an asymptote on either side of the domain that is not necessarily included, but gives you a perspective on where your graph should land. So the period determines what the asymptotes are going to be like. The very same K you use to discover what the period is the very same K that you figure out what your asymptotes are. And let's see how that works out. So asymptotes basically are minus 90 degrees and 90 degrees, but with the period in check, we have that as negative 90 degrees divided by K, and 90 degrees divided by the absolute value of K. So for your K equals to half or 1 over 2, this is what your asymptotes are going to look like. For the purple graph, your K is equals to, we're dealing with the K of a half. So that means on the left hand side, this is the asymptote negative 90 degrees, and the asymptote is the absolute value of a half, which is equals to negative 90 times 2 over 1, which gives us negative 180 degrees. So here is the negative asymptote for the green graph. It will be at negative 180 degrees. That's where it is. That's negative 150. That's negative 180. So we put the asymptote there. And we're going to make it green so that you can see which graph it matches with. Okay, we make it green. And now let's duplicate this on the right hand side. So we should also find another, there is the 180 degrees. So now notice how your center branch domain is now matching with your K and the period. So it is between negative 180 degrees and 180 degrees for y equals to 10 of theta over 2, and so on and so forth. So this is how you decide and figure out what your period is going to be like, and how and what your asymptotes are going to be like. Now, once you discover that on the center branch, the rest is easy to duplicate. So what you do is, for the next asymptote on the right hand side for the graph, remember the period was 180 degrees, right? The period is 180 degrees. You just add 180 degrees to your last asymptote. So 180 degrees, 90 plus 180 degrees, got a calculator, don't use your head here. 90 plus 180, which is the period for the red graph where k equals to 1, that lands us at 270 degrees. So the next asymptote will be at 270 degrees, which is here for the red one. Okay, let's make it red. For the red one, that will be, and then on the other side, it will be at negative 270 degrees, and so on and so forth. Now, that's how you duplicate your periodicity. Easy peasy. Now, for the intercept, you will see how that is also easy to duplicate. You also use the same method. You take out what is in the middle one, which is 0 for this case, and then add 180 or whatever the period is for that graph, either to the right or to the left. And that is how you easily duplicate your graph and make it so much easier to draw the graph. So your y-intercept is going to be still at the origin, and your x-intercepts will depend on what your period is, what your k is. So you look at where your asymptotes are, find the middle one right in the center, at the center, which is the origin, and then take it from there. Add whatever period applies for that function that you're working with to the right and to the left. You will figure out easily where your x-intercepts are. Now let's look at an example to illustrate what we've just learned. Example 1. Sketch the following functions for theta is between negative 180 and 180. For each graph, determine the period, domain, and range, x and y intercept asymptotes. Okay, now you've got the graph. Here are the graphs. Okay, I'm going to do a few of the periods so that you can see how easy it is. Notice that your k's are different, so your periods are obviously going to be different here. So your k for the first one is 2. We know that the period here is 180 degrees divided by the absolute value of k, which is supposed to 2 in this case. So that becomes 180 times, you flip this upside down at the bottom, so that's 2 over 1, and that gives you, no, 1 over 2, sorry, not 2 over 1, sorry, 1 over 2, excuse me, 1 over 2, and that is equals to 90 degrees. That is for this one. That's the period for that one. The period for this one is exactly the same thing. Notice that your negative is taken care of by the absolute value. It will become a positive. So that will be 180 degrees divided by the absolute value of negative 2, which is equal to 2, which then leaves us with 180 degrees multiplied by, flip this one at the bottom upside down, that is 1 over 2, which leaves you with exactly 90 degrees. So the period, regardless of the sign of k, will still remain exactly the same. Now let's do the period for the last one. Period for the last one, let's do the period for k equals to 3 over 2. So that's 180 degrees divided by the absolute value of 2 over 3. Now that becomes 180 degrees multiplied by 3 over 2. We flip that upside down. Take out a calculator. Common fraction button, 180 multiplied by 3. Downward arrow and put 2. If you're using a Casio, that is equals to 270 degrees. That's how easy it is to calculate what your period is going to be like. Remember, your asymptotes also follow the same fashion. On the left one, you'll have a negative 0 over the absolute value of k. And then calculate accordingly. On the right, you'll have 90 degrees over the absolute value of k and calculate accordingly. That is your center branch. As soon as you've got that center branch sorted out, you can duplicate that to the right and to the left by adding your period, whatever the period for that particular function is. Now, to save time, I've drawn all this and collected them in a table, put them all in a table. So I've done for each and every one of us of these ones functions. We've got your details. All of the characteristics are now put in a table in the next slide. So here are the, starting with the standard one, which was not necessarily included in the question, but we're going to draw it for reference purposes so you can see how the graph changes based on what the characteristics now are affected by your k. So now this is the red graph will be y equals to tan theta, the standard one, and then the blue one will be y equals to tan to theta. The green one will be that, the purple one will be that, and the black one will be that. Now here is the period. For the standard one, it's 180, easy peasy simple. For y equals to 2 theta, like we calculated, it's 90 degrees. Same as the other one of 9, y equals to minus 2 theta. And then for y equals to 3/4 of theta, that will be 240 degrees. And for the last one, it will be 270 degrees. The domain for the standard one, negative 90 and 90. The next one, negative 45 and 45, same as with this one. These two have exactly the same parameters or characteristics. Of course, the shapes are going to be different because remember, notice that your tan of negative theta is equals to negative tan theta y. Look at the cast diagram. Let's look at the cast diagram. Negative theta is here. This is how you find negative theta. That is from 0 to this direction, the clockwise direction, which is the opposite direction of the normal one, which is anti-clockwise. From here, anti-clockwise. That is the positive direction for calculating your theta. Now this is a negative direction, so that lands us with a negative theta. Notice something. Tan is positive here in the first quadrant and the third quadrant, but negative in the second and fourth quadrant, which is where your negative theta lands. That's why you have tan of negative theta equals to minus tan theta. And that's how you end up with that. Keep that in mind. Now, okay, let's take this table and now apply it into drawing the graphs. Okay, we're gonna start with the standard one because that is the easiest to draw. In other words, in fact, I encourage you to start with the standard one all the time so it gives you a much better perspective. Now the standard one is very simple. Step number one, let's look at the asymptotes. The asymptotes are at 90 degrees and negative 90 degrees, so we're going to start with that. Here's the first asymptote on 90 degrees. Let's duplicate that on the left-hand side, negative 90 degrees. Done. We're done with our center branch. This is our domain. The domain is between negative 90 degrees and 90 degrees of the center branch only, not including the ends, negative 90 and 90 degrees. That is just the middle branch, the center branch. We don't need to really worry about the other side. On either side, we can figure that one out using the repeated pattern ability of these graphs. Now, step number two, we look at where our x-intercepts are and our y-intercept. Where is our y-intercept? Our y-intercept is at the origin in all of this. So the y-intercept and the x-intercept for that matter, the middle one is at 0 degrees for all of them. So now let's go. So that is the first x-intercept right in the middle. First x-intercept right in the middle. And then we add, what is the period for y equals to tan theta? It's 180 degrees. So we just add 180 degrees to 0 and we'll land at 180 degrees. That is the second x-intercept. On the left-hand side, same story. We subtract 180 degrees from 0 and we land at negative 180 degrees. Notice that that is the same modus operandi you use to figure out where your other asymptotes are. To find the next asymptote, you will add 180 degrees to the right to 90. So that's 90 plus 180 degrees, and that will land you at 270 degrees. But that is outside the range, so we don't worry about that. On the left hand side, same story. Now let's draw the graph. Got enough information. Remember, your A is positive, so no funny business here. We've got y equals to a tan theta, so it looks up. It is the normal standard graph of a tangent graph. That's where it looks. And here is the other side. On the last bit, that's what we have. That's what we have. And then we have on this other side, this is what we have. So now let's draw the graph. Okay, let me fix this one. I might need to fix this one. Let me fix this one. Okay, that is equals to. All right. Okay, now we're done with the y equals to tan theta graph. Now let's go to the blue graph. The blue graph has a period of, let's go back to the table. The blue graph has a period of 90 degrees. Same as with the purple graph, 90 degrees. So our center branch will have the domain of negative 45 degrees and 45 degrees. So that is the blue graph. Okay, 45. Okay, 30 and 60. This is 45 in the middle of them. So let's use the blue color to match the graph that we are drawing. Now let's duplicate that on the left hand side. Negative 45 lands right in the middle of these two. Now in order to duplicate the asymptote, let's add, the period is 90 degrees for the blue graph. So let's add 90 degrees to 45. So we go 45 plus 90. And the next asymptote will be at 135. That is between 120 and 150. So that's our next asymptote there. 135. Here is the next asymptote. And then the next one is on the negative side, negative 135. There is the asymptote. And now we work on the x-intercepts. The one right in the middle is at 0, 0. All right. The x-intercept. And then on the right hand side, we add the period of 90 degrees. So at 0, that is the one right in the middle. Okay, let's draw that. That is the x-intercept for this graph. Okay, let me put it right in the middle. There we go. All right, now we add the period of 90 degrees to 0, and that will land us at 90 degrees. That will be our second x-intercept. Plus another 90 degrees, which is the period, and lands up at 180 degrees. On the left-hand side, same duplication. 0 minus 90 degrees lands us at negative 90 degrees, and subtracting another 90 degrees will end up at negative 180 degrees. Now let's draw the graph. Okay, what is the y-intercept? It's 0 for all of this. It's at the origin. Now let's draw the graph. Okay, it's a normal standard graph, so let's draw the graph. There are the asymptotes. Asymptotes are essential because they help you draw the graph more easily because they contain the graph. You don't make silly mistakes that way. So the asymptotes are important. You get the asymptotes first and everything follows without a problem. And the last bit on the left hand side will be at the top, and the last on the right hand side will be at the bottom. And that's how it goes. We're done with the blue graph. Let's now move on to the green graph. Asymptotes first. Okay, the period is 240 degrees. The asymptotes are at negative 120 and 120. Let's go. 120, negative 120. Okay, let's get 120. There is the 120. Okay, so we're going to have a green asymptote here. I'm going to change the color. Just be patient. Let's change the color to match the graph we're drawing. So that will be green. And now let's duplicate it on the left hand side. Negative 120. That's where it lands. Okay, that's negative 120. That's where the other asymptote lands. Notice that to the right and to the left, you will need to add a period of 240 degrees because that's what the period is. And obviously, the next asymptote to the right will be outside of the range for this one. And on the left-hand side, same scenario. Now, let's look at the x-intercepts. That is right in the middle at 0. X-intercept is right in the middle at 0. Here it goes. There is the x-intercept right in the middle. Now, to the right of that, the next one to the right will be 240 degrees away. Now, 240 degrees is outside of the range, so we don't worry with that one. On the left-hand side, same story. Now, what we can do is, we know that our graph is standard. Here is the standard. Our A is positive, so we're going to have a standard shape, meaning that our graph will look up. So we'll take it from the middle. Notice that we need to make sure that we use our asymptotes as the borders. Asymptotes. Here is how we use the asymptote as the border. On the left hand side, there is the left hand side on the other border. Now notice that we've got a piece that is left between 120 degrees and 180, and the same for negative 120 and negative 180. That is not catered for. How do we figure out what that piece looks like? So what we do is we go back to the original equation. Y equals to 10 of 3 quarters of theta, right? And we substitute the value of the ends, 180 degrees and negative 180 degrees. In this case, we've got 10 of 3 quarters of 180 degrees. At 180 degrees, this is what we will have. So we go 10 in brackets, common fraction button, you go 3 times 180, downward arrow to 4, right arrow, bracket on the right, and that is equals to negative 1. So that is equals to negative 1. Let's calculate the other one as well at negative 180 degrees. That is equals to, same story. So instead of 180, we're dealing with negative 180 this time. And that will give us positive 1. Which makes sense because remember 10 of negative theta equals to negative 10 theta. And 10 of theta equals to theta. 10 of theta. Alright, so now that gives us, at 180 degrees, we've got negative 1 as the point. 180 degrees, that's negative 1. Here is negative 1. 180 degrees, negative 1. Let's change the color to green. Okay, here is the point, negative 1 at 180 degrees and 1 at negative 180 degrees. Yes, and that is how we deal with that. Now let's plot that bit. Here is how we plot that bit. Okay, so it should go down. over here it should go up, and this is why it goes up, how it goes up. Let me fix that. Right. And over here it should go down, and this is how it goes down. Let me fix that. There. That's how it goes. We're done with the green graph. Now let's deal with the purple graph. Remember, the purple graph has got the same borders as the blue graph. We're not gonna waste time. Same everything, same period, same asymptote, same everything. Intercept as well. So where the blue graph is, we also must put the purple graph. Let's start with the asymptotes. Okay, purple asymptotes on top of the blue ones. Okay, here is the purple asymptote. Now duplicate. Okay, so here is the other one on the left hand side. Okay, and then we have another one on the left hand side, then another one on the right hand side there. Exactly where the blue asymptotes are. Okay, same with our x-intercepts. They are exactly the same place. You will see what's different between the two. So the first point is at the origin, the second point is at 90 degrees, and the third point is at 180 degrees. On the left hand side, negative 90, and then minus 180 degrees. And now we join the graphs. Notice something. The graph of the blue and purple graph, this is where they differ. The purple graph now changes shape. It looks the other way. They have the same asymptotes, same intercepts and everything, but the direction where the graph of the purple one looks is different from the blue one's direction. This is it. Now we go. Instead of going down over here, it's gonna go up, and instead of going up on this other side, it's going to go down. So this is what we have. Let me fix this one. And that's how the graph of the purple y equals to 10 of minus 2 theta looks like. Almost identical in every respect to the blue graph, except for the shape now is upside down. It's reflected about the y-axis. All right, now let's plot the last graph, y equals to 10 of 2 theta over 3. The period here that we're dealing with is 270, and here is the domain and the asymptotes, negative 135 and 135. 135 is over here. 135 is right here. So we've got the black one here on top of the blue and purple graphs. We're gonna have a black one. Let's change the color to black. Now let's duplicate that color. On the left hand side, negative 135. There we go. All right, now the intercepts are right in the middle too. Let's make that black, right in the middle. Okay. Notice how the asymptotes can basically, the next point is going to be 270 degrees away, so it's outside of range. Okay, we're going to do the same thing as we did with the green graph, and you'll see exactly now what we do. All right, so now let's draw the graph. It's y equals to 10. It's a standard graph. It's not negative. It does not have a negative does not have a negative angle, so it's a standard graph. It will look up. Now let's join them together. This is what the graph will look like. Let me fix the other side. That's what it looks like. Now on the ends, we're going to have to do what we did with the green graph. We're going to figure out what your theta is. Your whole y value is at 180 degrees and minus 180 degrees. So we go back to the function. We go 10 of 2 over 3 times 180. That is equals to 10 of common fraction button 2 times 180, downward arrow 3, right arrow, close bracket, equals to, that gives us negative square root of 3, which is when you press the S to D button, gives you negative 1,73. That's negative 1,73. Knowing the duplicity of the 10 graph, the negative bit, where you've got negative 180 degrees, will give us the negative of that, which is will be positive 1,73. You can even use a calculator to just double check that. Okay, I'm doing that exactly now. So I am inserting the negative and see what happens. Exactly, it gives me square root of 3, which when I press the S to D button gives me 1,73. So we've got that sorted out. 1,73 and minus 1,73. So on the positive is negative, and on the negative it's positive. So we've got a negative 1,73 on positive 180 degrees. That is negative 1. That is negative 2. That is negative 1,75 there. So that will be negative 1,73 right below the 1 3/4 line. So we put our point there. Right below that. And on the other end, we put it on the positive side, but right there. That's where it fits. So now let's connect the 2 points. So this one is going to go this way. And this one is going to go that way. So let me fix this one. And now let's look at what the graph is going to be look like when you use a graph calculator. This is basically how you draw all your tangent graph of the form y equals to 10 of k times theta. Now let's look at what it goes exactly the way. Let's compare, and that is how the graph should look like. Now moving on, let's look at number 3, functions of the form y equals to 10 in bracket theta minus p. Now let's look at the effect of p. In all types of functions, p, or where it is stationed, can be any variable. P basically indicates your shift to either the left or the right. Now if your p is positive, in other words, when you've got 10 of theta plus p, that means your graph was shifted p units to the left. If it's negative like this, 10 minus p, then it means your graph is shifted p units to the right. For example, y equals to 10 theta is not shifted anywhere. It's right in the middle. Now notice that you've got a black one instead of a red one, and you will see why that is the case in a few moments. Now this one is shifted minus 60 degrees. It's shifted 60 degrees to the right. How do we then figure that out? By just looking at the graph. Okay, this is where the red graph is supposed to sit, right? The standard mean one. All right, now this one is shifted, the blue one is shifted 60 units to the right. So let's count 30, 60, and that's the blue graph. So you just look at the milestone here, the x-intercept right in the middle, and then you count 60 degrees to the right, 1, 2, and then you draw the graph accordingly. Of course, notice that your y-intercept also changes but you'll be able to calculate that by just punching in your 0 in the equation, and it will give you what the y value is. All right. Now for the green graph, that is shifted 90 units to the left. Plus 90 means 90 degrees to the left. Compared to the standard graph right in the middle, let's see. We've got this right in the middle. Let's count 90 degrees to the left. 1, 2, 3. And that's where you should get the green graph, and that's where you get the green graph. This one is shifted 60 degrees to the left. The purple one, let's see. 1, 2. And there is the purple graph. And the rest of the milestones, you just duplicate like you would with any other. For example, to find the next place where it has an x-intercept, you just add 180 or subtract 180 from this. So you go negative 60 minus 180 degrees, and it will land you right where the next one should be. And then you draw accordingly. Notice that the period for all of this is 180 degrees. It does not get affected that way. The only thing now we're focusing on is the shift to the left or right. Your K is 1 in all of this, so your period remains 180 degrees. Very important to note that. So your period is still 180 degrees because your K is equals to 1 in all the cases. Now let's look at the characteristics in general. But before we do that, let's look at what happens with tan of theta plus 180 degrees. Remember, I told you it replaced the red tan theta graph. How did that happen? So basically, this is what we did. We shifted the graph 180 units to the left. Notice what happens. 1, 2, 3, that is negative 90. Another 3, 1, 2, 3, that is negative 180 degrees. You get another one. And that's exactly where the graph of y equals to tan theta landed. On the right, you also count 180 for the next x-intercept, 180. And there is the next intercept in the other graph. Same with the asymptotes. You figure out what the asymptotes of the main branch right in the center are, and then add 180 degrees to find the next asymptote, and so on and so forth. Now let's look at the characteristics of functions of the form y equals to 10 in bracket theta minus p. Your domain for the middle branch is now shifted. Instead of it being between negative 90 and 90 degrees, notice that the shifting also affects the positioning of the domain. In other words, the asymptote. So that's what the asymptote is going to be. Negative 90 degrees minus p, 90 degrees minus p. That's where the asymptotes lie. The period is still 180 degrees, and the range is still y is an element of all real values. That hasn't changed. The x and y intercepts will depend on how the graph is shifted to the left or right. The y-intercept will be at 0 degrees and f of 0 minus p. And then the x-intercept will be at p and 0. All right, in other words, the shifted part, right? And then to figure out the next x-intercept, right, you will have to add the period, which is 180 degrees in this case, or subtract the period, depending on whether you go into the right or to the left, on either side. Now let's look at example 2, which will illustrate how we deal with functions of the form y equals to tan of theta minus p. Sketch the following functions for theta is between negative 360 degrees and 360 degrees. For each function, determine the following: the period, domain, and range, x and y intercept, asymptotes. Exactly the way we dealt with the first example is exactly how we're going to deal with this example. And the functions are tan theta plus 45, tan theta minus 30 degrees, tan theta plus 60 degrees. This one is shifted 45 units to the left, this 30 units to the right, this 60 units to the left. So that should be easy to compare that with the graph of y equals to tan theta, which is not shifted either way. Right, so the period is still the same. Let's keep that in mind. Period is still the same. Okay, let's change the color back to my favorite color. Period is still the same. Period for all of this, period will still be equals to 180 degrees. So no need to manipulate the period over there. It's straightforward. Now, what changes is the restrictions on the domain inside, but the domain will basically be between negative 360 degrees and 360 degrees, with the asymptotes depending on how the graph is shifted. Remember, you shift the asymptotes together with the graph and you will see exactly how that works out in a few seconds. Now let's start with the standard graph that is not shifted in any way, shape, or form. But before we do that, let's look at what the complete table looks like. Okay, for the tan of theta, all the periods are exactly the same. All right. Now the domains depend on the shifting. They are the domains. The range is exactly the same. The y-intercept depends on the shifting as well. The x-intercepts also depend on the shift, right? And the asymptotes also depend on the shift. Remember, the period is 180 degrees and the domain is between negative 90 degrees and minus p, and 90 degrees and p on the right hand side of the center branch. Now let's draw the first graph, the standard one. So you can see how the shifting now is applied in each and every one of the graphs. Right, let's start with the red graph. So let's go back to red. Okay, first, the asymptotes. Asymptotes of the red graph, y equals to tan theta, are easy, between 90 degrees and negative 90 degrees. This one is not shifted. Okay, so let's start with that. 90 degrees. Oh, sorry. Okay, let's draw the asymptotes. There is your 90 degrees. We're going to change that color to red so it matches the graph. Okay, let's change that to red. And now let's duplicate this to the left hand side, minus 90 degrees. Now, in order to figure out the next asymptote, you add the period, which is 180 degrees. So 90 degrees plus 180, 90 plus 180, that lands us at 270 degrees, and that's where our next asymptote lies. So let's duplicate this. Okay, this is where 270 is. That's our next asymptote. The next asymptote is on negative 270 degrees. All right. And now let's look at the x-intercepts. The first intercept is right in the middle because this one has not been shifted. It's right in the middle. So that's the x-intercept right in the middle. There, it's 0. So it's right in the middle at 0. Okay, right in the middle at 0. And the next one is 180 degrees, which is the period, away from 0 on either side. So the next one is at 180 degrees. There's the next one. The next one, 360 degrees. On the left hand side, negative 180. Okay, negative 180 and negative 360. Now that we're done with the x-intercepts, the graph is a standard one. We'll look up, no manga business here with the A. So now let's draw the graphs. So starting from the x-intercept, that's how you draw the graph. On the next branch, this is how you draw the graph. Just duplicate it. Next branch, same story. Starting from the x-intercept, moving out. Okay, let me fix this one. Then on the last branches, this one will be up there. Then this one will be down there. And we're done with the red graph. Easy peasy so far. All right, the blue graph, Notice the blue graph has been shifted 45 degrees to the left. Plus means to the left, 45 degrees to the left. So we take the branch, right? And the asymptote. We take that, and we also take the x-intercept right in the middle. It's been shifted 45 degrees to the left, so that's the first intercept, where it will be the first x-intercept. All right, this is where it will be at negative 45 degrees. And then to figure out the rest, you just add or subtract the 180 degrees as the need arises. So 180 minus, subtract the 180 degrees from minus 45, so that's negative 45 minus 180. The next intercept will be at negative 225. Negative 225. There is negative 225. That is the next x-intercept. Next one, subtract another 180. That will land you at negative 405, which is outside of the range. To the right, we go negative 45 plus 180. Negative 45 plus 180. That takes us to 135. So here is the next x-intercept. 135. And the next one, we add another 180 to 135. And that lands us at 315, which is here. 315. There. And that will be the last on this interval of between negative 360 and 360 degrees. And now let's deal with the asymptote. Asymptote should also be shifted 45 degrees to the left. All right, the first one was at 90 degrees. We're shifting it 45 degrees to the left. There is the shifting 45 degrees to the left. Everything is shifted 45 degrees to the left. That is the first asymptote. Now let's duplicate that. Next one will be, okay, the next one will be at, okay, let's see, 45 minus 180. 45 minus 180. Negative 135. That's where we land. Negative 135 is where we land. This is where we must be. Next one, negative 135 minus 180 lands us at negative 315. Negative 315. Let's harvest this one. Negative 315. There is negative 315. All right, the next one to the right of 45, that's 45 plus 180. 45 plus 180, that gives us 225. So that's 225. Let's duplicate that. 225. Here is 225. There is 225. The next one will be 180 degrees away. So 225 plus 180. That is 405, which is outside of the range. And that is the last of the asymptotes we have. Now that we've got our x-intercepts to guide us, we can now draw the graph. So we can now draw the graph where we can. So let's draw the graph where we can, starting from the intercept. And we take it like that. The standard graph, so we draw it in a standard manner. Okay, another branch completed. Another branch completed. Now that we've completed all the branches, now let's figure out where the pieces that are left will take us. Okay, this one will be easier to complete because it just goes this way. Let me fix that. It goes down like that. Now, what is not going to be easy is figuring out what happens in this space between 315 and 360, which is easy because all we do is we just substitute 360 degrees and minus 360 degrees into the original formula and calculate. Let's do that. So we've got 10 of 360 plus 45. Take out a calculator. Let's calculate what that is. So that is 10 of 360 plus 45, close bracket, and that is equals to 1. Then on the other side, 10 of negative 360 plus 45. That is equals to, let's see, 10 of negative 360 plus 45. That's on the left hand side. That is equals to also 1. So we've got 1 on each one. Okay, let's see. Let's plot them. 1 at 360 degrees and 1 at negative 360 degrees. That's where we land. Okay, so now we connect them. This one is how we're going to connect this one. And that's how this one is connected. And that's how this one, on the other hand, is connected. It's going up. That's the piece and how we connect it. All right, we're done with the blue graph. Now let's draw the green graph. The green graph is shifted 30 units to the right. Okay, so from the standard one, which is the red one, we go 30 to the right. So let's shift this asymptote 30 to the right. So 30 to the right will take us to what? 210. So 30 to the right. This is where the asymptote will land us. That's the green one. So let's make the color green as well. Now let's duplicate this. Okay, so everything will have a shift to the right compared to the red one, 30 degrees. So where there is the standard one, the red one, we just take it 30 degrees to the right. Okay, just fixing that one. Now let's duplicate this one as well. Okay, 30 degrees to the right. Notice our red is over here, so we just shift 30 to the right. Here's another red asymptote. Let's just land this one right 30 degrees in front of it. We don't have any other asymptote that are red. Let's see. Negative 240 minus 180. Let's see where we land. Negative 240 minus 180. That lands at negative 420. So that's outside of the range. So we're done basically here. Now the same thing goes for the intercepts, but not the y-intercept. Okay, the intercept. Okay, let's the x-intercepts there. X-intercepts. We'll move 30 degrees to the right. That is 30 degrees to the right. There. Another one there to 10. Then another one will be outside of range at 390. Okay, to the left, we're going to have this one over there. Here is an x-intercept, 30 to the right. Okay, this 30 to the right. Another one over here, 30 to the right. There. All right. Now let's connect what we can. Okay, from the intercept to the asymptote. Intercept to asymptote. Intercept to asymptote. Here's another one. Intercept to asymptote. This one will go up. Okay, let's fix that one. It will go up like this. And then the pieces that are left, it's between 300 and 360. So let's figure out what 360 is. F of 360 is over there, and on the left hand side, negative 360. All right, so we go the green graph. Okay, that is 10 of 360 minus 30 degrees. And that gives us, calculator, 10 of 360 minus 30. That's what we have at 360 degrees. That's negative square root of 3 over 3. The S to D button gives us negative 0,577, which is negative 0,58. Next one, also 10 of negative 360 minus 30. That gives us 10 of negative 3 theta minus 30. That is equals to negative square root of 3 over 3, which when we press the S to D button also gives us negative 0,58. So they both have the same y-intercept, negative 0,58, negative 0,58. Okay, so negative 0,5 is over here. Negative 0,5, that's negative 1. Negative 0,5 is there. Negative 0,58 will basically be right here below. Negative 0,58, that will be down there. And then on the other one, same story. Yeah. Okay, so we join this. How do we join this? Okay, so basically this is going this way. It's about to turn. Then about turn. All right. On the other side, it gives us the last bit of the piece that goes that direction. Okay, and that is the green graph drawn. Now the purple graph has been shifted 60 units to the left. When we have plus, that's to the left. Shifting left and right basically is you're twisting your mind. If it's plus, left. If it's negative, right. All right, so we shifting this 60 units to the left, 60 degrees to the left. So we go back to the red graph and we count 61, 2. Okay, 1, 2. So that's where the first x-intercept will be. Let's shift the asymptotes first. 1, 2. So this is where the purple asymptote will be at 30 degrees. Let's draw that there. Okay, let's change color. Now let's duplicate this. All right, now we're going to have to take, okay, let's see. So that was shifted 60 to the left. This one will also be shifted 60 to the left. So that's 1, 2. That's where the next one will land. The next one will be here. This is where the next one will be. And the next one will be 30 degrees to the left of this one that is red. Basically, that's how you duplicate. Okay, on the right hand side, okay, so that's 30 degrees plus 180. Let's see. The next asymptote, 30 degrees plus 180. That lands us at 210. That's 210. This is where it lands us. 210. Okay, next one, 210 plus 180. That is 390, which is outside of range. Now let's duplicate the x-intercepts without having to look at the table. Okay, the first intercept was here at 0. So the first one will be at negative 60. And there is negative 60. 30, 60. There is negative 60. Negative 60 is there. Let's change the color. Negative 60. No, not the green one. I'm not trying the green one. It's the purple one. Okay, 1, 2. There is the purple one. Okay, so it lands us at negative 60. Negative 60 minus 180, that will be the next one. It's negative 240. Negative 240. There is negative 240. Minus 180 again lands out as negative 420, which is outside of the range. Okay, to the right, we've got negative 60 plus 180. Negative 60 plus 180. That gives us 120. 120 is right here. This is 120. Next, 120 plus 180 gives us 300. So 300, here is 300. There is 300. So that's where we land. Okay. Next one is outside of range at 480, so we don't count that one. And now we use the asymptotes and the x-intercepts to draw the graphs. Starting from the middle one. Okay. There's a branch. Okay. Next one. Let me fix this. perfect, but this is where it should go. Right, next one. The next one should be coming right down here. All right, now the last bit at 360 and negative 360, this is how we calculate them. We go 10 of 360 plus 60. That is equals to, take out a calculator, 10 of 360 plus 60. That is equals to square root of 3, which when we press the STD button gives us 1,73. On the other hand, negative 360 plus 60, 10 of negative 360 plus 60, that gives us square root of 3, which is 1,73 as well. So that gives us 1,73. So on either side, 1,73, 1,5 is this, 1,75 is there, 1,73 is just under there. This is what, no, sorry, 1,73 just under there. Same story on the other side, 1,73. This is where it lands us. Now let's connect the pieces. So this one will go up and this one will go down, up as well, like this. Okay, let's fix that. There. And that is how you draw the shifted graph along the x-axis of the tangent graph. It looks like a whole web of, it's because of the... Now let's look at the graph drawn in a graph calculator. They're not supposed to cross, and that's how they're supposed to go. All right. Now let's look at example number 3, and this will demonstrate how to sketch the tangent graph. Example 3 says, sketch the graph of f of theta equals to 10 of theta, half of theta minus 30 degrees, 480 degrees, and 180 degrees. For theta is between negative 180 and 180. Notice something here before anything. Your k is 1 over 2. Let's change the color. The k is 1 over 2. Very important to note there, because then it changes things. Your k equals to, let's make this thicker. Your k equals to 120. 1 over 2. 1 over 2, meaning that therefore period equals to 180 divided by the absolute value of a half, which then is equals to 180 multiplied by, you flip this upside down, 2 over 1, which is 360 degrees. So we're going to have half of a graph in a normal period of 180 degrees. Notice that is also shifted somewhat to the right. So in addition to doubling the period, it has been shifted 30 units to the right, 30 degrees to the right. So keep that in mind. Okay, now the first thing we should do is figure out where our middle x-intercept is going to be. Or we can figure out where our domain is going to be. The asymptote. Doesn't matter what you start with, you can start with whatever works for you. Asymptote, okay. Under normal circumstances, your asymptotes should be at 90 degrees and negative 90 degrees. So what we do is you equate this whole angle to 90 degrees. Okay, so we go 1 over 2 in bracket theta minus 30 degrees equals to 90 degrees. That's the easy way of dealing with a complex question like this. Multiply throughout by 2, you're left with theta minus 30 degrees equals to 90 times 2, which is equals to 180 degrees. Now, therefore, theta equals to 180 degrees plus 30 degrees, which gives us 210. Take out a calculator and add these two. Don't try and figure it out on your own to avoid silly mistakes, especially in a test or exam. So that is 210 degrees. That is the first asymptote on the right. The one on the left-hand side, you simply take the period. The period is 360 degrees. The one on the left-hand side will be negative 90. So let's calculate that one. Asymptote 1. This is asymptote 1. Let's calculate asymptote 2. Asymptote 2 in general will basically be, instead of 90 degrees, because our period has been doubled, it will be half of a period to the left. So the milestone, which is half of a period, milestone in this case will be equals to period, which is 360 degrees divided by 2, and that will be equals to 180 degrees. So to find asymptote 2, we go 210 minus 210 minus 180. Now that should be minus 360. Okay, so let's plot that milestone. That's 210, and then we'll calculate 180 from 210. Okay, the second milestone will be 180 degrees from 210. No, it should be 360. Yes, it should be 360. So 210 minus 360 degrees. Let's see, 210 minus 360. That lands out as negative 150 degrees. So that's asymptote number 2. So asymptote 1 is on 210, which is outside of range, by the way, and then the second one is on negative 150 degrees. This one is in range, so that one is outside of the range. Okay, let's strike it off. 210 is outside of the range. Let's change the color to red, make it thicker. All right. And then on the left hand side, we will see. Now let's deal with the intercept. X-intercept. X-intercept will be at 0. That's the first one. Okay, so we equate the angle to 0. Therefore, theta minus 30 equals to 0. 2 multiplied by 0 is 0. Therefore, theta equals to 30 degrees, which makes sense. Now, to figure out what the next x-intercept is going to be, we add. So that's x-intercept 1, x-intercept 2. We will have to add 360 degrees. 30 degrees plus 360 degrees, which is equals to 390 degrees, which is outside of the range for this particular case. So it's outside of the range. On the left hand side, let's subtract 360 degrees. Okay, x-intercept 1, 2. Okay, on the left hand side, x-intercept 3, left. Okay, that will be 30 degrees minus 360 degrees, which is equals to 30 minus 360. That is equals to negative 330. This one is in range, so it works perfectly fine. Now, what is the y-intercept? Y-intercept, you make x 0. In other words, in this case, you make theta 0. Well, when we make theta 0, this is what we have. Y equals to 10 of half in bracket 0 degrees minus 30 degrees, which is equals to, take out a calculator, 10 of common fraction 1 over 2, right button bracket, and that is 0 minus 30, close bracket, another close bracket, and that gives you negative 2 plus square root of 3, negative 2 plus square root of 3, which is equals to, when you press the S to D button, that gives you negative 0, comma, 267, which is approximately negative 0, negative 0, comma, 27. All right, that's the y-intercept. Now let's see what we can draw. But before we draw this, we need to draw the standard graph of y equals to tan theta between 180 and negative 180. All right, let's draw the graph. Okay, let's draw the red graph first, so we have something to compare it with. So our asymptote will be at 90 degrees. That's the first thing. Let's reduce the thickness. Okay, duplicate, and the other one will be at negative 90 degrees. All right. And then your x-intercept will be at 0, 180 on the right hand side and negative 180 on the left hand side, because your period is 180 degrees. And now we join the points. So you're going to have a full period in between 90 and negative 90. Let me fix that. And then you will have this come down and this go up on either side. That's the red graph complete. Now let's draw the blue graph. All right, let's start with the asymptote first. Asymptotes for this one. Okay, the asymptote number 1 is 210, which is outside of range. The next one is negative 150. Let's go to negative 150. Negative 150. Here is the first asymptote. All right, let's make that blue. The other one is outside of range, so we don't have that one. All right, and then the first x-intercept is at x equals to 30 degrees. X equals to 30 degrees. Okay, there is the first x-intercept. All right, and the next x-intercept is outside of range. So 30 degrees plus 360 degrees. Remember, the period for the blue graph is 360 degrees. So 30 plus 360 is outside of range. So we're going to figure out what that bit is over there. Okay, so now let's draw this graph on the bit that we can find now. Okay, so this will be at the bottom. Like this. Okay, we're going to have to figure out what that point is, so let's calculate it. the tan of a theta. So that is the tan of, let's use the black, tan of half in bracket 180 minus 30 degrees. And that is equals to 10 common fraction button 1/2 bracket 180 minus 30 to close brackets. That's 2 plus square root of 3, which when we turn the S to D button gives us 3,732, 3,732, and so on and so forth, which is approximately 3,73. And then on the other side, negative 180 minus 30 degrees, that is equals to 10 of negative 180 minus 130 degrees, minus 30 degrees. That is equals to 2 plus square root of 3 as well, which gives us the same number when we press the S to D button, which is 3,73. So in both instances, we've got 3,73, 3,73, 3,73, which is outside of this range. All right. Outside of this range. On the other side is also outside of this range. But basically, this is what the graph will look like. This is how the graph will go on the right hand side. It will go like this. Something along those lines. All right, on the left hand side, so we're going to have a graph come somehow. From up there. So it won't show, but it's going to be coming from up there. And this is how the graph looks like in a graph calculator. And that's the bit that I tried to show. You see? So there is basically no bit here within the range. The other bit comes to the left of negative 180 degrees. And that's exactly what we have over there. Just to show that this is supposed to be up there. All right. So we don't have this in general. We just wanted to show that the bit is going to be up there. All right, so this is what the graph looks like. And that is how you draw the graph. Now for the last question, we'll look at number 5, how to interpret the tangent graphs. Example 4 goes, the sketch shows two functions, f of theta, let's zoom in, f of theta equals to a cos theta and g of theta equals to tan theta. For your theta is between 0 and 360 degrees. Point P, which is 135b, and point Q, C, -1, lie on g of theta and f of theta respectively. This on g of theta, the P, and the Q on f of theta. Determine the values of A, B, and C. The value of A, let's see. A is the cosine graph, and the cosine graph is this. And that shows you what the amplitude is. Whether it is positive or negative will depend on what the graph looks like. It starts with a maximum turning point as a minimum turning point in the middle, and another turning point, which is maximum at the end. So this is a positive A. Now, exactly what is the magnitude of A? Let's look at what happens from the point of rest to the maximum turning point. That's 2 units. And from rest to the negative turning point, the minimum turning point is -2. So your A is positive 2. That's how your A is calculated. That was number A. A equals to 2. So therefore, your graph of f of theta equals to 2 cos theta. F of theta equals to 2 cos theta. If you're not sure how to deal with the cosine graph, go look at the video for the cosine graph. Now the next one, number B. Okay, B is part of the point P, which lies on the tangent graph at -1. That is the y-intercept we're looking, okay, at P. Yeah, point P is there. Is that point P? Yes, that's point P. P is on 135 degrees, and it lies on the graph of G, which is tan theta. Okay, 135 degrees. Okay, so point P, 135 degrees, and that is B. Yes, 135 degrees B lies on G of theta. Therefore, G, which is tan of theta, therefore B is equals to tan of the angle is 135 degrees. Therefore, B equals to, take out a calculator, tan of 135, close bracket, and that gives you -1. And that is your B. Therefore, G of theta, okay, equals to tan of theta. Okay, the B equals to -1. Next one, we're looking for C. Okay, C is part of the point QC -1, and that lies on the graph of F. That lies on the graph of F. So Q point QC -1, point Q, QC -1 lies on F. F of theta, which is the cosine graph. And we know f of theta equals to 2 cos theta. Therefore, the y coordinate, which is -1 equals to 2 cos of the angle is C. Therefore, divide both sides by 2. You're left with -1/2 on the left hand side equals to cos of C. And now we find the reference angle. The reference angle is C is equals to cos to the -1 of +1/2. That's the reference angle. And that gives us, if you don't know how to solve the trigonometric equations, I'm going to do a video on that one, so don't worry, we're going to address all of this. So that's shift cos bracket 1, so that's common fraction button 1/2, close bracket, and that gives you 60 degrees. That is the reference angle. Okay, why the reference angle is important? Notice that your cos is negative at this point. Where is cos negative? According to the cos diagram, our cos is negative on the second and third quadrant. But this point is on the third quadrant because it's over 180 degrees. And how do we represent angles in the third quadrant? In quadrant 3, your angle theta is equals to 180 degrees plus the reference angle, which is 60 degrees, and that is equals to 180 plus 60, and that is equals to 240 degrees, and that is the angle there. Let's look at the angle. This is the angle here. It's over 180 but less than 360 degrees, so it's 240 degrees. Less than 270 degrees also, so that's 240 degrees. Therefore, C equals to 240 degrees. Therefore, C equals to 240 degrees. So your A equals to 2, B equals to -1, A equals to 2, B equals to -1, and your C equals to 240 degrees. Now let's look at number B. What is the period of G? The period of G of theta is tan of theta. Your K is equals to 1. Your K is equals to 1 here. Therefore, the period is self-explanatory. It's equals to 180 degrees. K equals to 1. Okay, that's number B. K equals to 1. Therefore, period equals to 180 degrees. Number C. Solve the equation cos of theta equals to half graphically and show your answers on the diagram. Cos of theta equals to half. Cos of theta equals to half. Notice that that is also equals to, when you multiply both sides by 2, that gives you 2 cos theta equals to 1. In other words, we're looking for where this graph of cos theta equals to 1, this point, in other words, where it is equals to 1. Let's reduce the thickness. We're looking at those points. Notice that you've got 2 points, this point and that point, and we need to figure out exactly what those points are, and we'll use the reference angle to figure that one out. Let's add another page while we add it. Okay, so let's solve this. All right, so we're solving for where K equals to 1. Now, what is the reference angle? Reference angle is theta equals to cos to the -1 of half, which we've already calculated to be 60 degrees. How you go about it is you press shift, cos, then common fraction button 1 over 2, close bracket, and that gives you 60 degrees. That is the reference angle. Okay, cos of theta equals to positive where? This is where cos is positive. It's on the positive. Okay, cos of theta is positive. Let's see. According to the Cartesian, the cos diagram, cos of theta is positive in quadrant 1 and quadrant 4. Is positive in quad 1 plus 4. Okay, in quadrant 1, we represent our angle as the reference angle. So it's equals to reference angle, which is equals to 60 degrees. In quadrant 4, the angle is represented as 360 degrees minus the reference angle, which is 60 degrees, and that gives us 300 degrees. And therefore, cos of theta equals to half when theta equals to 60 degrees and theta equals to 300 degrees. And the point where I showed on the graph is exactly where. These are the points. Okay, the first one is reduced thickness. Let's keep it blue. Let's duplicate it on the other side. Okay, that point is, this point is 60 degrees and that is 300 degrees. And there's other indications. Last question, determine the equation of the new graph if G is reflected about the x-axis and shifted to the right by 45 degrees. G is the graph of the 10, shifted right by 45 and reflected about the x-axis, meaning that it becomes negative. Okay, reflection shifted to the right. Okay, here is the new graph. Okay, that's number D. New graph of G. G of theta equals to tan theta. All right. Okay, when you reflect about x-axis, in other words, you flip it upside down, G of theta becomes minus tan theta. Okay. Now when you shift, okay, let's see the shift. When you shift the graph 45 degrees to the right, this is what happens. Shift 45 degrees right. This is what happened. G of theta equals to minus tan of theta minus that's minus tan of theta, okay, G of theta. Therefore, G of theta equals to minus tan theta minus 45. That's 45 degrees to the right. And that is the last bit of the question, and that is the final answer. We've come to the end of our video. Thank you for watching. See you in the next one. Bye.